why did I go and revise all of the grade 11 circle geometry with you guys before we started Similarity? Why do you think? Because the triangles are going to be located in circles. So the triangles we have to prove similar, we are going to have to use those triangle properties in order to prove that the triangles are similar. We're going to have to use Chord Theorem to prove two angles are equal in order to prove similarity. We're going to have to use angles in the same segment to prove that two angles are equal, and therefore to prove that two triangles are similar. So we're going to be using the circle properties or the circle theorems in order to prove similarity. Okay, sorry. So the next one says PB over there is a tangent to circle ABC. Now for those of you guys that still struggle with the grade 11 circle geometry, a couple of tips from me to you. I always go and when I read that little birthday card, so the moment the word tangent gets mentioned, you should immediately remember there are three things we know about tangents. First one, radius is perpendicular to tangent. But if there's no radius, you can't use it. Got it? Which if you look at that diagram, nope, doesn't look like there's a radius unless they tell me AB is the diameter. But we'll need to check on that. Then, secondly, tangents from the same point are equal. If there's no two tangents, you can't use that one. So generally, the one we use most often if I have a tangent is tan chord. Got it? So, we know this is a tangent. We are given the fact that PA is parallel to BC. We want to prove that triangle PAB is similar to triangle ABC. So, like I said, the lovely thing about it, let me just highlight these two triangles. Is that actually told you what the corresponding angles are. So the question then is very simple. Can you prove that angle P is equal to angle A? Not at the moment. Do you guys agree? So I move on to the next one. Can you prove that angle A is equal to angle B? Can you prove angle A is equal to angle B? Yes or no? Yes. Alternate angles. So I write that down. And remember to put those parallel lines, otherwise they're going to penalize you. Then, can I prove that angle B is equal to angle C? Yes or no? Come on. Yes, Oliver.
You can.
Why? Tan chord theorem. Absolutely. Angle B1 is an angle formed between a tangent and a chord, and that chord subtends C on the alternate side. So that, therefore, angle B1 is equal to angle C. And sometimes if you turn it sideways, you can actually see it a little bit better. Can you see? B1 formed with that chord AB, but AB subtends C. So B1 is equal to C, tan chord theorem. And the last one then can always be sum of angles of a triangle. So I can go back to that angle P equal to angle A2 because of sum of angles of a triangle. And therefore, triangle PAB is similar to triangle ABC. Reason, angle, angle, angle. So there's the A part. Then the B part. Now prove PA to AB, or PA over AB, is equal to AB over BC. So again, we can play with it over here, and we can say PA is over there, AB is over here, AB is over there, BC is over there. So again, sometimes, like I say, you write it down and you can't immediately see from the one step to the next step. Sometimes you might have to do two steps just because the first one was a little bit awkwardly written. Do you understand? So, especially if it's written like this, please understand it means PA over AB. So PA over AB. And if I follow the pattern, then PA over AB is equal to AB over BC, which means you can go here in one step. And that's just going to be similar triangles. Okay, then the last one. We want to prove that AP over BP is equal to AB over AC. Can we go there in one step, yes or no? Somebody said yes. Shall we try? AP is over there. So we already have it there. BP is over here. So I can go AP there over BP. So I just have to follow the pattern. So again, look, AP over BP is BA over CA or AB over AC. So yes, you can totally go there in one step. And that will still be similar triangles. Got it? Oliver?
How, just to see, how is that proving, really proving? Because technically, you could just be popping down the answer. They don't
Yes,
know
you
you're
can
working
actually
out.
just pop down the answer.
But they don't know you're working out. They don't know how you've managed to get
That is the advantage of these sums. I'm not saying do that. I'm not saying just write down what they want you to write down. Because we're going to get to more complex problems later on where one of the sides is not part of the two triangles, but one of the sides is equal to another one. Then they can see you cheated. You understand? So if there's the situation where in order to prove the proportionality, we first have to prove two other sides are equal before I can use the similarity of the two triangles. Then they can see you cheated. This, can they actually see you cheated? No. You can pretty much just write down what they want you to write down and go, look, similar triangles. Like that, done. So, if you run out of time, and you have already proven similarity, please don't do this unless you've already proven similarity, and you can't see anything, just write it down and put similar triangles. Chances are you'll get, if not all your marks, at least some of your marks. Okay, just don't do it if you have the time to do it. Okay. You might have mistaken B. B does not say PA times AB. B says PA to AB. That's a ratio. Which means, ratio means PA over AB is equal to AB over BC. That's not multiplied, that was the ratio, which means it's that fraction, so that's done. Do you understand? Okay, okay. Yes, no. Guys, remember, when we are proving similarity, we can't use sides in similarity. Why? Because it's the same shape, different sides. So even though, yeah, you're thinking about congruency. Even though we have a shared side, A and B, that is not a corresponding side because of in congruency, the equal sides are corresponding. But in similarity, equal sides can't be corresponding because they can't be the same size. You understand? So watch out that you don't confuse congruency. Because a number of times I've seen people try and prove similarity, and then one of the three things that they say is they say this side is equal to that side. That immediately is a fail. You can't tell me a side equal to a side when you're proving similarity. Got it?